Good evening. We'll start today the first webinar on the Bharat Heritage Series, in which we'll have some glimpses of science in ancient India or ancient Bharat. So the topic is glimpses of science in ancient Bharat. I am sure most of you are aware of contribution to science and technology, to philosophy, to many other fields from the ancient Bharat. I am just trying to refresh those knowledge that we carry from our forefathers. So to start it, let us look at this. In this screen, or in this, you see the pictures of different civilizations. All these civilizations, these four civilizations, Maya civilization, Greek civilization, Egyptian civilization, and Roman civilization. If you look at these pictures, one thing is very clear. All these four are Western civilizations. Some of them are extinct now. And all these four have huge structures. The structures that you see are huge. These are without the modern science. These structures were built without the modern science and technology. But these structures were there. This is about the West. Now come to the East. If we look at the East civilization, there are two prominent civilizations, Mesopotamian civilization and Harappan civilization, or Sindhu-Saraswati civilization. If you look at these civilizations also, you don't see huge structures because these are so old that the structures are destroyed, but we see the remnant of those structures, the towns, the planning, etc. we can clearly see in these civilizations. Now, there are two types of civilization we saw: the Western civilization, the Eastern civilization. The Eastern civilization is definitely older than the Western civilizations. As per our knowledge of history, most of these Harappan civilization maybe is the oldest after the Maya civilization. But Harappan civilization is very well organized. And you can see how they are organized, how the pictures or the graphics you can see. Look at the graphics and try to imagine what is there in these graphics. In the previous pictures and these pictures, let us try to imagine what is there in these graphics. Then we see the Vedic civilization, which is maybe a continuation of the Harappan civilization, may not be a continuation of Harappan civilization, may be a completely different civilization. Either of the two. We don't know for sure whether Vedic civilization is a continuation of Harappan civilization or Sindhu-Saraswati civilization. We will see that a bit later. But what we can see here, the architecture, the sculptures, the intricacies in the constructions, all these are clearly visible. And if you look at this, these structures are of 1250 CE, the current era, or 6th century BC, or 1160 of current era. So these are all in the period before British came here, before the British rule in India, before the British gave us any marvelous structure like the Bombay railway station, these structures were existing in India. So this Vedic civilization was there. Now, looking at all these three, you can see one thing is very common. In all these three, the pictures or the structures have circles. The pictures or structures have cylinders. They have rectangles. They have different types of geometric structures. Now, even today, it is very difficult, almost impossible, for a common person to draw a circle with free hand. Just take a pen or a pencil and try to draw a circle. Most of the people will fail to do that. A proper circle, it cannot be drawn. In those days, thousands of years ago, people without the modern scientific equipments could draw these circles, could draw these cylinders, etc. How was it possible? How was it possible? And that is a question. That is a question that we'll investigate, which means they must have some knowledge, some scientific knowledge, or some knowledge was existing at those periods, because of which they were able to do this. Now, what are those knowledge? Let us try to understand that. So, that knowledge in today's world, we can say that those were the knowledge of geometry, or in India what we call geometry. So let us look at the geometry in Bharatvarsha. When India was known as Bharatvarsha, in those periods, what is the geometry? Now this geometry or geometry was embedded in the mythology of India, in the devotion that people were used to in India. These were also embedded in the pseudoscience. You can call the mythology as pseudoscience, and these were embedded in science. Now, whether they are all intermingled or they are separate, that we are going to investigate in this webinar. And now we will consider particularly four aspects of Vedic civilization, which emphasizes that there was good knowledge of geometry among the people of ancient Bharatvarsha. In the Bharatvarsha, people had knowledge of geometry. That we will discuss from four examples. These examples are Sri Vidya or the Tantra tradition, then the Kalpa or Yajna that we used to do our household, then the Shilpa, and that is the construction of temples, etc., then Jyotisha. These four, we are going to look into these four aspects and see how geometry was embedded in all these aspects that Indians or the ancient Bharatvarsha people were used to. So let me start with the first one, which to most of us is a superstition, which is a mythology in India, and many people with devotion follow this, the Tantra tradition or the Sri Vidya. So let us look at what is the Sri Vidya. The definition, by definition, the Sri Vidya is a guiding principle for worship of Sri Lalita Parameswari Devi as the epitome of cosmos and nature both. So Lalita Parameswari Devi is worshipped as the epitome of cosmos and nature, and the process is this tantric tradition. It heavily the worshipping heavily depends on or heavily relies on yantras. Yantras is another name for geometry in the ancient India. So it heavily depends on geometry. Now, since it heavily depends on geometry, let us look at the jantras. What are the jantras that are used in Tantra or that are used in Sri Vidya? These jantras, they are believed to be the manifestation of God themselves. So in the yantra you will find God. These are revered as layouts where each vertex, each line, each corner, each of them holds a deity. People will meditate on this yantra. Once this yantra is made, people will meditate on this yantra as a part of a spiritual practice process to achieve their requirement. So, and they will have something in mind that I need this, I need good amount of money. So for that there is a particular yantra, Lakshmi yantra. So we will meditate on that. In this meditation, what people do is they meditate starting from the outer ring, they navigate towards the center of the yantra. They will meditate at the center of the yantra, and everywhere, every corner, every line, everything is containing a deity. This is an example from old palm leaves of how to follow the yantra to the center so that you can meditate. Meditation is ultimately completed at the center. How to follow it to its center? This is an example from old palm leaves. Now these yantras, if you go to any temple, in most of the temples, these yantras are carved on ceilings of the temples, floors of the temples. You can find different types of yantras like Sri yantra, the Ganesha yantra, and then Lakshmi yantra, Kali yantra, Vairav yantra, etc. Now if you look at these yantras, take a close look at these yantras, particularly the Sri yantra. All these yantras, particularly the Sri yantra, but all these yantras are symmetric. All these yantras, construction of these yantras is complex. And in these yantras, there are circles, there are triangles in different proportions, and these are to be drawn to a high precision to the level of pixel. That is point number one. The yantras are to be drawn in high precision to the level of pixel. Then second is these are complex two-dimensional structures. These are symmetric. There is symmetry. So these are symmetric. Then the most important part is the area of each of the entity, like the triangle. So there will be three triangles. Their areas will be related. There is a circle. Its area is related to the circle of the triangle. So, handling the complexity, handling the symmetry, and maintaining the relationship between the different portions of this in this yantra is completely impossible unless one has good knowledge of geometry. So looking at these yantras, we can safely conclude that in the Bharatvarsha, people had good command over applied geometry, and using those commands, they were able to construct these yantras. That is the conclusion we can draw from Sri Vidya. Looking at Sri Vidya, forget about the spiritual aspect of Sri Vidya, but just look at the Sri Vidya, for which Jantra is the most important part, and for looking at the Jantra, we can conclude that a sound knowledge of applied geometry is necessary. So people had sound knowledge of applied geometry. Although there was no modern instrument, they were able to draw these complex geometrical structures. Then let us come to the second part of Jyamiti or geometry, which is through Shilpa Shastra. So the Shilpa Shastra people say that the temples or churches or mosques, these are all pseudoscience, so I'll add pseudoscience to this with mythology and devotion. Now what is Shilpa Shastra? Shilpa Shastra is the guiding principle for temple architecture, temple construction, and temple sculpting, so etc. So sculptures, constructions, architecture, everything, layout of the temple, these all are guided by Shilpa Shastra. There are many books on Shilpa Shastra available in ancient India, like Shilpa Shastra itself, Manasara, Vastu Shastra, Shilpa Ratnakosha, and many more. There are so many books, texts available in India. If you now, these are earlier, these were not available to common people. Now these are available to us, to everybody on internet, through the internet. With the advent of internet, these are all available to us. So we can search in the internet and get any of these Shilpa Shastras. Now, one of the important part of the temple is its pillar. As we know, temples are epicenter of Vedic art, culture, and heritage. These pillars show us the art, the fine art is available on the pillar. The sculpture on the pillar, the architecture on the pillar gives us glimpses of the art, fine art that was prevalent in those days in these huge structures. So they show that Shilpa Shastra is giving us knowledge of geometry. Without knowledge of geometry, it is impossible to carve these structures. These intricate and blended structures is almost impossible to draw without good amount of knowledge of geometry. It is also difficult to understand how to do this. So geometry in Shilpa Shastra, this starting from the basic block, the pillar in temple, we can say that Shilpa Shastra contained good amount of geometry. So geometry was an integral part of Shilpa Shastra. Now, in these pillars, if you look at the pillars, in the pillars there will be different deities, different designs will be on the pillars. They depend on the deity that is being worshipped in the temple, or and these are specific carvings according to the scriptures. For example, scriptures like Agama, Manasara, or Shilpa Shastra, they decide which will be the design, what is the design on the pillars. So these are all, these designs, they all require good knowledge of geometry. The Shilpa Shastra specifies specifically the geometrical guidelines on the construction and carving of different kinds of pillars. It also gives the structural and aesthetic guidelines in building of the pillars and the temples and other parts of temple arches. Similarly, the arches of the temple, they are also like the pillars. They are defined how the arches are to be done, are defined in Shilpa Shastra. The beauty is all these things, all these instruction regarding the construction of arches, the layout, the build-up, etc., is given in terms of in the form of Sanskrit shlokas only. So there is no mathematics involved, nothing is involved. Only in the form of Sanskrit shlokas, they describe, the Shilpa Shastra describes the construction of temple. So geometry is embedded within or in the mythology itself. Then finally, the most beautiful part of the temple is its vimana, or these are the most catchy part of the temple. These are called Gopuram or Vimanas. Shilpa Shastra definitely explains how these are layered, how these are sculpted, both for structure as well as aesthetic sense. Geometrical principles are well blended in each of the description for these vimanas, for the pillars, for the arches, etc. Which means the geometry, what applied geometry is also included in Shilpa Shastra. So Tantra Vidya, applied geometry is there. People had knowledge of applied geometry in Tantra Vidya or Sri Vidya. People had knowledge of applied geometry through Shilpa Shastra. Then we will come to Kalpa Sutra. Kalpa Sutra is all this. Mythology is there, devotion is there, pseudoscience is there, and we will see science also is there in Kalpa Sutra. The Sutra of for Kalpa Sutra, this comes from the Vedas. These are integral part of Yajurveda. Kalpa Sutra is a integral part of Yajurveda. A shloka from Yajurveda is Namaste Astu Bhagavan Vishveswaraya Mahadevaya Trayambakaya Tripurantakaya Trikagni Karaya. Remember this Trikagni Karaya Karagni Rudraya Nilakantaya Mrityunjaya Sarveswaraya Sadashivaya Sriman Mahadevaya Namah. This is a stuti or in praise of Lord Shiva or for Mahadeva. It means that I salute the Lord of the universe, the great Lord with 3 eyes, who destroyed Tripura the demon, who determines the time when the 3 sacred fires are lit. Trikagni Karaya means 3 sacred fires. When the 3 sacred fires are lit, we are going to discuss about this Trikagni Karaya. Trikagni. So 3 sacred fires are lit, who being Rudra consumes the universe as fire, who has blue throat, who has conquered death, the Lord of all, the ever auspicious one. Salutation to glorious and great Lord. So this is the meaning of this shloka, but we will be interested only in one part, Trikagni Karaya. Trikagni is the important part. We'll look at that Trikagni for the geometry. These are the guiding principles for Yajna rituals, and it has practical applications in theological aspects of Vedas. Now, as we started in the beginning of this section, we said sutras, Kalpa Sutras. What is sutras? When you say sutra in Odisha or in India, most of the parts of India, sutra, if you translate that to English, it will be principle and formula. Both of these will be there. It can be principle, it can be formula. But in English, to my knowledge, there is no formal definition of a formula, or there is no formal definition of a principle. But in Sanskrit, there is a formal definition of the sutra, which is the principle or formula. The definition is Srapakyaram Asandidhyamo Sarabadha Vistato Mukham Astovam Anavadiyamacha Sutram Sutra Vido Vidu, which means minimum number of alphabets, unambiguous, concise, universal, which is true, universally true, non-redundant, Astovam means non-redundant, Anavadayamacha, which without a flaw, Sutram Sutra Vido Vidu is, this is called a sutra. What is called a sutra? Sutra has minimum alphabet, it is unambiguous, it is concise, it is universal, it is non-redundant, and it is without a flaw. So these sutras we are going to look into. These sutras we will start with the Kalpa Sutra. We are starting with the Kalpa Sutra. In the Kalpa Sutra there are two parts, Sauta Sutra and Sulabha Sutra. Sauta Sutra is dealing with mantras, rituals and execution of yajna, whereas Sulabha Sutra is the applied geometry part. This is preparation for yajna. We will concentrate on Sulabha Sutras, which is the preparation for yajna. In the ancient India, Sulabha Sutra was used for constructing fire altars, for yajna vedis, even for construction of temples, etc. So any construction, people use Sulabha Sutra. There are different rishis who gave different Sulabha Sutras. So the contributing rishis are Bodhayana. This may be the oldest Sulabha Sutra, which is more than 3000 years old. By conservatively you can say it is 3000 years old, but it will be definitely much more than that. Then Apastamba, Satyasadha, Maitrayanya, Katyayana, Manava, Badula and Varaha. These are the different. These are the 8 different Sulabha Sutras which are available, and these are compilation. Basically, these are compilation of geometric principles which are used in different constructions. Now, the meaning is Sulabha means a rope or a thread. Sutra means principle or formula. We have given it. So Sulabha Sutra is formulas for construction using rope. For example, you can use this to construct a fire altar for yajna. In the old days, old Indian tradition, every household used to have a fire altar for yajna. Every household, one of the daily rituals was performing a yajna. So now let us come to the Tetagni, the 3 fires. So this is Tetagni is the 3 fire altars, and these 3 fire altars, the caveat on these 3 fire altars is they are of equal cross-sectional area. There are 3 altars. One is called the Ahavaniya. Ahavaniya is the for the Vedic rituals we use this. This is square in nature. So this is a square fire altar. Then we have Grahapatya. This is for household purpose like cooking. This is circular. Its cross-sectional area is circular. Then we have Dakshinagni. Dakshinagni is a token of respect for ancestors. The cross-section of this altar is semicircular. So we have a circular, we have a semicircular, and we have a square structure. These are the three cross sections, and the area of these three cross sections is same. Now you can imagine how difficult it would have been in those days to design something like this. Today it looks much easier. To design a square, you can easily construct a square. Then as you know the formula, so from the square we can find its area, then find out a circle, radius of a circle using the formula for circle. Then we design a circle. Similarly, we can design a semicircle. All these will be of same cross-sectional area. But when these formulas were not known, when we are talking about this is thousands of years ago, when these formulas were not known. We didn't know these formulas from the West. West even didn't know these formulas. So in those days, how difficult it would be to construct this. Three cross sections with three same area, cross-sectional area. How difficult it would have been, you can imagine. Let us see whether we can do that. Now, if we are constructing, then we require measurement. So, for construction, you require measurement of length. In the old days, there are no SI unit or CGS unit, etc. In those days, the least count was kilo. Kilo means length of a sesame seed. Then, on the angula. Angula is if you put 34 sesame seeds or 34 kilos, one by one, one after one, so head to tail in that manner, that length which will be around 4 inches or 5 inches today in today's measurement, that is angula. Then one pulsa. One pulsa is 120 angulas. Why people use kilo? The reason is, for us, this is the oldest known oilseed crop in those days. That is why it was used for measurement. Now, let us draw the square. Try to construct a square. Only caveat is, the constraint is, the sides of the square will be aligned with cardinal directions, and we cannot use a compass or a geometry box or modern equipment. So that we cannot use, but we have to design or construct a square. So let us construct a square. So how to proceed? How to proceed for constructing a square? What people used to do in those days is, they took a pole, so erect a pole vertically on the earth, plane surface, go to a plane surface, to a field, erect a pole vertically, then draw a circle with the pole at its center using a rope. Using the rope, draw a circle with the pole at its center. Then mark the points where the shadow of the pole crosses the circle in early morning and early evening. These 2 points that we mark are the east and west points. So they are aligned to cardinal points east and west. Then mark the points where the shadow of the circle crosses the circle in the early morning and evening. Then take the diameter along that direction, connect that, then along that direction take a diameter which is equal to the length of the square. So suppose it is 10 angulars or 5 angulars, so diameter should be 5 angula. If the side of the square is 5 angula or 3 angula, the length will be 3 angula, the diameter will be 3 angula. So take that diameter along the east-west direction. East-west direction has been found out. So take that diameter, then draw a circle through those two. Then on the circle of taking this east point and west point as the center, draw 2 circles, 2 other circles. So at the east point draw a circle, at the west point draw a circle. They will be touching each other, they will be tangential to each other, they will touch each other at a point. To that point, draw a straight line meeting the path circle at two other points. So where it meets the path circle, those are the north and south points. So mark the points on the path circle where the line crosses. Then at those points, which are now marked new points, draw again two circles. So taking the north point as center, draw a circle. Taking the south point as a center, draw a circle. Now where the outer four circles cross each other outside the central circle, those points, mark those points. Then those join those points. If you join those points with straight lines, then you get a square with sides aligned to cardinal directions, and the side length is the required length of the square. So this is how the people used to design squares by aligning them in the cardinal directions in the ancient Bharat. So this is a geometric knowledge that people had in ancient Bharat. Today you can prove that this is a square in the cardinal directions and its length has the required length. That we can prove today. But in those days, without knowing the proof, without anything, they used to draw this square. Now the second part is transforming the square into a circle of equal area. So what we will do is, what they did in those days is, they took the square, then found its center. So how to find the center is easy. Just take the diagonals, whatever the diagonal, two diagonals, cross that point is the center point. So they took that. Then with that as the center, and they drew a circle which is encircling the square, which embeds the square. Then from the center, they draw a perpendicular to one of the sides and extended it to meet this circle. So from O, they meet the circle at P. Then QP, they divide in the 1:2 ratio. So 1/3, Q1 is 1/3 of QP. Then you draw a circle with O as the center and OR as the radius. This circle will have the same area as the square. This is how they used to draw a circle of same area as the square. Then finally, we have to transform the circle into semicircle of equal area. So that we will get all the three categories. So for that, first draw from the circle, draw a square. As we discussed earlier, draw a square. Then take the diagonal of the square as the diameter and draw a circle. Then again, as we discussed, extend this diameter as a crossing the side of the square vertically, and it should meet there. Then take 1/3 of that diameter. If you take 1/3 of, take 1/3 of this length between the side of the square and the perimeter of the circle, great circle. So then you draw the circle. Then half of that circle, take the semicircle of this new circle. That will be of equal area as the earlier circle. So this is how people used to draw three yajna altars, fire altars, These are of same cross-sectional area, and without any knowledge of modern geometry, they had their knowledge of geometry. People had enough knowledge of applied geometry in the Silva Sutras, and they used to do this. So this is for day-to-day home ritual. So yajna that is performed in home. Now the yajna that is performed publicly. So those public yajnas are for different purposes, like for prosperity, for destroying enemies, for food prosperity, for land acquisition, etc. And each had a different city. City means the altar, fire altar is called a city. In Sanskrit it is called city, we call it fire altar. In English it is called fire altar. So this city has different names corresponding to different shapes. This is an example of Kurma city. Now these cities are made up of many bricks. So this is a Kurma city. The Kurma city consists of 5 layers. So one layer of brick, above that another layer of brick, that way 5 layers of bricks. Now you can see that the layout for the odd number of layers and the layout for the even number of layers are different. So layer 2 and 4 are different than compared to layer 1, 3 and 5. And the structures you can see, you have triangles, we have squares, we have rhombus. So all types of structures are there in this Kurma city. But we will not consider this Kurma city, we will consider the Shayana city. This is another design, the Chakra city, Ratha Chakra city. Here also you can see everything is there. All types of geometrical structures are embedded in this, starting from rectangle to circle to triangle, so everything to trapezium, everything is there in these structures. This is an example of Siena city. Siena city, or it gets its name from Falcon city. So Siena city or Falcon city, Falcon fire altar. This is an example of that. So in this, the shape is like a falcon. This is only one layer that you are seeing. This is only one layer, just the layout. But this also has 5 layers. Total there will be 5 layers. Each layer will have 200 number of bricks, not more than 200 bricks, not less than 200 bricks. So each layer has 200 bricks. The layout for the layer 1, 3 and 5 is shown on the right hand side. Layout for the layer 2 and 4 are shown on the left hand side. If you look at this, total is 1000 bricks. Types of bricks are triangular, right angle triangle, square, rectangle, rhombus. So all types of these bricks are there. This is an isometric view of the 5 layers of the Siena city. And this is the actually constructed Siena city. The beauty with this, or the complexity with this, is the bricks are to be designed in a proper manner, because the bricks have to be baked. When the bricks have to be baked, they will be, after baking, they will be sinking. So when that is to be taken into consideration when the bricks are made, otherwise one will not get the proper shape. To get the proper shape, one has to consider that in addition to the shape of the brick, to the size of the brick. So shape, size, then after baking they are sinking. Everything is to be considered, and they have to be layered. They have to be placed in proper manner to get these cities. So you can understand how much complexity is involved in designing a city in those days. So with that, we come to know that people had knowledge of complex geometry and application of those geometry in construction. Now, if we know that, and we have seen the Sindhu Saraswati civilization, we have seen the Vedic civilization, let us see if there is a possible link between Sindhu Saraswati civilization and Vedic civilization. Look at this. The Sindhu Saraswati civilization or Harappan civilization. If you look at this, you can see the brick is properly a rectangular brick with, it is a rectangular brick with 90-degree corners. Everywhere we have 90-degree corners. All the corners are 90 degree. Then you can see a well. Well is a circle. So they had knowledge of circle. They had knowledge of 90 degree. Getting 90 degree bricks, designing 90 degree bricks. They had knowledge of this. So two knowledge were prevalent in the Sindhu Saraswati civilization. These two knowledge were there. Now come to the Vedic civilization. In the Vedic civilization, we saw the cities were using right angle triangles. So in both the civilizations, right angle is prevalent and circles are prevalent, from which we may say that the Vedic civilization may be an extension of the Sindhu Saraswati civilization. It may not be an extension, but there is a probability, there is a small probability that it is also an extension of the Sindhu Saraswati civilization, because both of them were constructing circles, both of them were constructing 90-degree triangles. Now, talking about 90-degree triangles, right angle triangles, how can we forget Pythagoras? So we discuss about Pythagoras theorem. So whether these people had knowledge of Pythagoras theorem, we are talking about thousands of years old civilization. Pythagoras theorem came in about 500 BC. So did these people have knowledge of Pythagoras theorem, which came at 500 BC, but this civilization was much before that? So definitely they didn't have the knowledge of Pythagoras theorem in the form that Pythagoras gave it. We'll consider what Pythagoras gave. We'll see that. But the Pythagoras theorem that we know today actually came to us by Euclid, which is after 200 years of Pythagoras. He documented the theorem. This shows the document. You can see there. Now before that, you look at this Plimpton 322. This is basically a Babylonian clay tablet. It dates back to about 1800 BCE. This shows the Pythagorean triplets in 3 columns. If you look at the 3 columns, the Pythagorean triplets are there. Pythagorean triplet means this 3, 4 and 5. 3 square plus 4 square is equal to 5 square. So 3, 4, 5, they constitute a Pythagorean triplet. Similarly, all the numbers, other numbers that form this, which satisfy the relationship a square plus b square is equal to c square, they form a Pythagorean triplet. So this was available in Babylon about 1300 years before Pythagoras discovered his theorem. Then this is the Rhine papyrus. Rhine papyrus. Rhine papyrus, you can see this is also a written mathematical document which gives a worksheet of ancient Egyptians. You know, Egyptians were very fond of triangles. Look at the Egyptian civilization, and you can see they were very fond of triangles. So it is not very astonishing that Pythagoras triplets were also written back in 1500 BC by Egyptians. That is also not very astonishing. Then there is a Berlin papyrus, number 6692. It says it is something like a Pythagoras theorem, but not exactly the Pythagoras theorem. It gives you a problem. You are told the area of a square of 100 square cubits is equal to that of two smaller squares. The side of one is 1 by 2 plus 1 by 4, the side of the other. What are the sides of the two unknown squares? This is a question, and this is in Berlin Papyrus, which indicates that this is also people also at that time they also knew the Pythagoras theorem. Now, with all those, let us say what Pythagoras told us. As his theorem, when Pythagoras proposed his theorem, what did he propose? Did he propose p square plus b square is equal to a square, which is perpendicular square plus base square is equal to height square, hypotenuse square, or he proposed hypotenuse is equal to square root of perpendicular square plus base square? Is it possible for him to propose this? A hint to this question, a hint to the answer of this question is this: the West, they accepted Arabic numerals in the 10th century, and you try to prove that III square plus IB square is equal to B square, because before 10th century they were using Roman numerals. In the Roman numerals, it is almost impossible to find the square of a number, and it is, to my knowledge, completely impossible to find the square root of a number. Therefore, it is not possible that Pythagoras would have told or would have given his theorem in either of these two forms, which we read in the school or which we teach in the school as the Pythagoras theorem. It is not possible either by Pythagoras or by Euclid to give it in this form. So this was not given by Pythagoras. Somebody else must have given this. So what Pythagoras would have told and what others would have told, let us examine that. So to examine that, let us come to this Bodhayana Silva Sutra, which was about 800 to 400 BC, much before Pythagoras. So it says that I am not going to read out the Sanskrit sloka that is written at the top, but I will divide it into different sections, and each section I will read out. So Dirgha Chaturastra, that means a rectangle. Consider a rectangle. Akhyanaya, which is the diagonal. Rajju, take a rope. Parshvamani, perpendicular. Niryatamani cha, horizontal. Jak pruthak bhutekuru, area of the sum of the squares. Chaduvaya karoti, equals area of the diagonal. Which means the meaning of this Sanskrit sloka, which is given in Bodhayana Silva Sutra, it says that take a rope, stretch it along the length of the diagonal of a rectangle, that will produce an area which is the vertical and the horizontal sides make together. This is what Pythagoras has told as his theorem, that if you take a right angle triangle, then the area formed by the base and the perpendicular taken together is the area formed by the hypotenuse, when the area being considered is the area of squares. That is what Pythagoras proved. So what much before Pythagoras, and Pythagoras proved that areas are, these two areas is equal to the third area. That was proved by Pythagoras, not numerically, but by comparison. So this was also done by Bodhayana, much before Pythagoras. But this theorem is called the Pythagoras theorem. Then comes the more interesting point, which says, the sloka says that Saya mamama yama gunam vistaram vistarenapu samasya vargamulam yataktani tadiddoviddu, which means multiply the length of a right angle triangle by the same length and the breadth by the breadth. The square root of the sum of these two results gives the hypotenuse, which is the proper Pythagoras theorem. This is given by Manava-Sulva Sutra. This was in 750 to 690 BC, much before Pythagoras. Pythagoras gave his theorem. Pythagoras was around by 570 BC to 490 BC. So it is much before Pythagoras, and this formula was available in India through Sulva Sutra. So, although we don't know them, I am not sure if any of you is aware of these slokas and these things, the Pythagoras theorem much before Pythagoras in India. So then the question is whether Pythagoras could know, or whether people could know this from India. Is it possible that they knew it from India? You can see the timeline. If you look at the timeline, 300 BC is Euclid's steel element, Clinton 322 is 1800 BC, and then 1500 BC is Rhind papyrus, and 800 BC is the Bodhayanam. So it is because of the trade routes, it is possible that the knowledge has traveled from India to Greek. That is perfectly possible. And there is another thing with that also, which we can say that it is not sure that it was given by Bodhayana. The knowledge must be existing much before Bodhayana, but during that period, Rishi Bodhayana, he only encoded that. He only wrote that, compiled that, but the knowledge was existing much before that. That also one can say. Then what are the other uses of Sulva Sutra? One of the uses is construct a square equal to the area of a given rectangle and vice versa. Construct a square equal to 1/3 of the area of a given square. Construct a square equal to 3 times the area of a given square. Construct a square equal in area of sum of 5 triangles, etc. There can be many more like this are available. These are some of the other uses of Sulva Sutra. For example, construct a square equal to 3 times the area of a given square. So take this square, then construct a rectangle with one side as the corner of the square or the diagonal of the square, and one side as the side of the square. Then take the diagonal of the rectangle and construct another square with that diagonal as the side. That will give you the required square, which is 3 times the area of the given square. This is available in Katyayana Sulva Sutra. Then transforming. So construction is there. Transforming a square into a circle of same area, into a triangle of same area, transforming a circle into square of same area, transforming a triangle into square of same area, and there are many more like this. Let us look at an example. In this example, it says Mandalam Chaturastram Chikiparnam Chiksambha Pasyabda Sabhagakuta Tutva Dababut Dhare Shepa Karani, which means if you want to design a square which is of equal area of a circle, Then take the circle, divide its diameter into 15 equal parts, then design the circle with the side which is equal to 13.33 part of the diameter of the circle. So this is transforming a circle to a square of equal area. So with that, we come to the final part of the Jyotisha Shastra in India, Jamiti in Jyotisha Shastra in India. This is particularly very misunderstood part. Jyotisha is misunderstood. There are lots of misconceptions. This is taken as pseudoscience in India, etc. This has two parts actually. The astrology, which mostly deals with cultural elements of predicting the future, and astronomy, which is the study of celestial bodies. The first part is pseudoscience. We can say it is pseudoscience. We can neglect that. We'll consider the second part, the astronomy part of the Jyotisha. So to compute the planetary motions of the celestial bodies, what we require is we require the knowledge of mathematics. So because of that, using that we will compute the planetary positions in Jyotisha. Which is required, planetary position is required both in astronomy and astrology. In ancient India, the observations were made, Jyotisha observations were made out of Ujjaini. Ujjaini is very important in Jyotisha because the placement of Ujjaini is exactly on Tropic of Cancer. And in old days, the zero meridian of the ancient India passed through the Ujjaini, which means the counting of day starts from Ujjaini. As per the ancient Indian tradition, even today in the Panjika, it starts at Ujjaini. Later, the meridian was shifted to Greenwich by the British after colonization of the world. So since 1884, the meridian has shifted to Greenwich. Before that, it was through Ujjaini. That is one important aspect of Ujjaini. Another important aspect is at Ujjaini, Lord Shiva is worshipped as Mahakala. Mahakala means he is the Lord of time and Lord of death. So it deals with time and it deals with death. And with that knowledge, people to understand that people from different parts of India came to Ujjaini, and it produced a lot of astronomers and mathematicians who contributed greatly to Indian mathematics. And these mathematicians, before 3000 BC, we don't know who were these. After that, Aryabhatta, Varahamihira, Brahmagupta, so these are all the mathematicians who produced or contributed to the Indian astronomy, like Surya Siddhanta, Aryabhatta Siddhanta, Aryabhattiya, Pancha Siddhanta, Brihamchita, Brihabjataka, etc. And they use different instruments like Chakrajantra, Golojantra, Sakarajantra, then Chapajantra. So the number of jantra is, each jantra is identified by a number. That number is given in the table, from which you can see which astronomer used which jantra. These are the examples of some of those jantras which are available at Ujjaini and at Jaipur. This, if you have time or if you get chance to visit these places, you should go to the ancient observatories and look at these jantras. Take a look at these jantras. These are magnificent geometrical structures. The jantras use geometry like anything, magnificent geometrical. Now, how mathematics is related to Jyotisha? We said mathematics is related to Jyotisha. How? Because the most important factor in time computation in Jyotisha, the most important factor is time computation. And in time computation, the most important factor is to find out the time rate of change of planetary motion. So the moment rate of change comes, which means there is contribution to calculus. Then calculation of ratio of planetary positions. So the ratio of planetary positions means there has to be knowledge of trigonometry. Then constructing these equipments that we saw. So they require knowledge of geometry. So Jyotisha gave rise to these three important branches of mathematics: calculus, trigonometry, and geometry in ancient India. That is the contribution of calculus. Now, what is the importance of geometry in Jyotisha? Importance of calculus and trigonometry we'll see later. What is the importance of geometry in Jyotisha? The geometry, to find out the importance, the geometry is used for calculating the radius of the planets. Trigonometrical observations to calculate relative position of the planets, and for design and manufacturing of astronomical equipments like astrolabes. Now, all this that we discussed up to now, we said about calculus is there, and we have discussed about circles, because the planets, people in those days, they knew the planets are spherical in nature, so they knew that they have to find out the area of the sphere or area of the circle, area of the circumference. So that required the knowledge of pi. Without the knowledge of pi, is it possible to find the area of a circle? That was done, as we know, Greeks, they discovered pi in the 3rd century BC as a constant. But before that, without using pi, is it possible to find the area of the circle? That was given by Borahomir, not very old, but old timer definitely. He says that area of the circle is equal to half the circumference into radius. Now in those days, if you are given a circle, then and you are given a rope, you can always measure its circumference, you can always measure its radius. So it is easy to find the area of the circle. Now did he knew, or did people knew what is pi? Was there any knowledge of pi? So look at this shloka. Chaturadhikam satamasta gunam davasista astata sahasranam ayutabda ayutabdavi kambha syasano brata parinaya, which means add 4 to 100, multiply it by 8, add to 62,000. This is approximately the circumference of a circle whose diameter is 20,000. Which means using this you can find out pi, a constant, the ratio between the circumference to the diameter. So pi is equal to 62832 divided by 20,000, which is equal to 3.1416. So correct value of pi up to 4 decimal points was given by Aryabhatta. So in Aryabhattam, he has given this. So as a constant, you can find out pi. So beyond that, is it possible? Was it possible to know what is the value of pi? Because as you know, pi you can go up to infinite number of decimal points. So that also was given by Madhava in the 1200 CE, current era, 1200 current era. Pi is equal to 4 into 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 up to infinity series. So this is the First infinite series for pi was given by Madhava way back in 1200 CE, current era. That is also, the infinite series is also representation of integration by parts. So integration was known to them, calculus was known to them. This one is the stepping stone of fundamental calculus because of integration by parts. This is why we say Jyotisha is root of calculus. Now this series was given by Gottfried Leibniz in the 17th century. So this series is also known as Madhava Gregory series, not the Madhava series who originally gave this, but it is known as Madhava Gregory series. Now finally we come to the last part, which does not contain any mythology, any devotion or any pseudoscience, which is pure science, that is gravity, about gravity in Bharatavarsha in the ancient days. About gravity, there is a compilation on gravity by the Rishi Kannada. The compilation is called Vaisheshika Darshanam. So Vaisheshika Darshan is available on internet. You can download it and read it, and you will find many many interesting points related to gravity. This Vaisheshika Sutra of Rishi Kannada describes the principle of fundamentals of nature. It says that the nature consists of 8 elements. The 8 elements are Prithvi or earth, Apas or water, Tejas or fire, Vayu or air, Akasa or vacuum, Kala that is time, Diga is space, Atma is self, Manasa is mind. So these are the 8 constituents of the cosmos or the nature. It also classifies motion. So that is how it classifies nature, then it classifies motion. It classifies motion into 5 categories. Utkhepanam, which is the upward movement, Abhakhyapanam, which is the downward movement, Apunchanam, which is contraction, Prasaranam, which is expansion, Gamanam, which is horizontal movement, Karmani, which is the types of motion, which says that these are the types of motion. Out of this, we are going to consider only the Utkhepanam. Now, for Utkhepanam, or the upward motion, the constituents of upward motion are Gurutva, Prayatna, Samyoganama, and Utkhepanam, which means Gurutva means gravitational force, Prayatna is effort or external, the external effort put in the upward direction, so upward force. Then Samyoganama means confluence or joining of these forces. Then Utkhepanam is upward motion. So upward motion is a result of the effort, upward external upper force effort and the downward gravitational force. That is what is shown here. Suppose from the earth you want to throw a stone or any body, material body above. So if you throw it upward, then you are doing a prayatna. When you are throwing it, you are doing a prayatna. Prayatna means it is an external upward force on the object or on the stone or on the body. Then on that, because of the weight or because of the mass, Gurutva, so there is a gravitational force which is acting downward. So there is a upward force, there is a downward force. If their resultant is in the upward direction, then there is Utkepana or there is upward motion. So upward motion is the resultant of Prayatna or effort and Gurutva or gravitational force. Now let us come to, based on that, let us come to laws of motion. In the laws of motion, Rishi Kannada says that karma is common for motion of bodies in collision or in separation. That is the first stroke. And the second stroke says that bodies cannot produce own force, which must be external. So force has to be external, and there will be the force or karma is common for motion. If there is motion of bodies in collision or separation, which means if the bodies are in rest or are in motion, for the motion the external force is required. So karma or force is necessary for the motion of bodies in collision or separation, which cannot come from within the bodies, but has to be external. That is what Rishi Kannada says. Now, does that strike a chord in the mind? Just compare it with the Newton's first law. An object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced, which means net external force. So both these statements are similar, although they are not exactly same, but they are similar to a large extent, which means the first law of motion was also known in a different way in India to Rishi Kannada. In his compilation, he has mentioned this. Now let us look at the second law. Particular effort results in particular impulse. This law says that a particular effort results in particular impulse. Newton's second law, what does it say? It says the rate of change of momentum of a rigid body is directly proportional to the force applied on the body. So if you apply a force, that results in a momentum, a rate of change of momentum, or that results in the change of momentum, which is impulse. So particular effort results in particular impulse is also similar to the Newton's second law. So both these laws were prevalent in India. Then the third law. Third law, Rishi Kannada says, karya virodhi karma, which means the effect or the karya always opposes the action or the karma. Newton's third law is, to every action there opposes an equal action. So both these are again equally same. Both these laws are similar. So that we saw that the Indians had knowledge of motion, laws of motion. Indian had knowledge of gravity. Now, let us see whether after Kannada, whether people knew about gravity or not before Newton, after Kannada. So after Kannada, here is a shloka from Pancha Siddhantika. From the Pancha Siddhantika, if you look at this shloka, the meaning of this Sanskrit shloka is, as here among human, the flame of a fire ascends upward. So flame always is the upward direction. Ascends upward, and a heavy body thrown up descends down to the earth. So does it happen below among the demons. So important part is this. The flame of a fire ascends upward, and a heavy body thrown up descends down to the earth. So anything that you throw up will come down to the earth because of gravity. So there was some knowledge of gravity in Pancha Siddhantika. Now the origin of the word of gravity, the gravity word is derived from the gravis. Now gravis is a Latin word which means heavy, and guru in Sanskrit means heavy. Gravis and guru, if you compare them, you can say that this guru, as it moved to Latin area, it has become gravis. And guru means heaviness or massfulness. So gravity's origin is also in guru. Finally, we will discuss about Gurutvakarsanam. Gurutvakarsanam means the attraction towards the center of the earth. You can see this Alberoni's India. If you look at Alberoni's India, in the Alberoni's India, he describes Brahmagupta as work. In the Brahmagupta's work, Brahmagupta says this. The translation in Alberoni's India, it says this: all heavy things are attracted towards the center of earth. That in Sanskrit, Brahmagupta mentioned it as Gurutvakarsanam. So the Madhyakarshana or Gurutvakarshana, that was also prevalent in ancient India. So we can say safely now that people in India, ancient India, knew sufficiently about geometry, sufficient about applied geometry, sufficiently about calculus, trigonometry, as well as gravity and laws of motion. With that, we come to the end. This gives the evolution of gravity, starting with Maharshi Kannada. Then Aristotle, he gave the concept in the West. Then Varahamihira, then Brahmagupta, Alberuni, who translated Brahmagupta's work. Then Galileo, who started the modern concept. Then Kepler, from whom Newton derived everything. Everybody has contributed. You cannot say that it is only Maharshi Kannada. Newton has his credit because he gave all these laws in a empirical form that Maharshi Kannada or his predecessors have not done. So Newton's credit is going to that. But the knowledge was prevalent, knowledge was existing, that we can say that this knowledge was also existing in India. In early India, this knowledge was existing. With this, let me come to my gratitude. My gratitude is to Project Shivoham, from which I gathered most of the information, then to Google and YouTube, finally to Deepak Kumar Naik, who actually gave me this idea of webinars on Indian heritage. So with that, we come to the conclusion. Thank you for your patience of hearing me out. If you have any questions, if you have any comments or questions, I'll be happy to address that, or I'll happy to listen to your comments. And we can do one thing. Please switch on your camera so that we can take a snapshot.
Hello, sir. I'm audible, sir. I'm Sambhu, sir.
Yes, Sambhu.
Sir, thank you, sir, for this beautiful presentation.
Thank you.
Actually, after listening all this presentation, something in my mind is that why in our Indian education system, these things are not included. So many things I came to know for the first time from this webinar. Like, for example, gravity. So Newton has been given all the credit in our education system. No idea about this Kannada. So why it cannot be included in our education system? I think it should be a part of that.
I will say that you are very correct. Hopefully, the government of India in its new education policy is going to include such things in its curriculum, because they are asking for the opinions on what is to be included in curriculum. Many people are, to my knowledge, I am giving my opinion that this should be in the curriculum. You give credit to Newton, no problem, but you also give credit to Kannada. So those things that we are giving opinion, you also give opinion. Everybody should give their opinion, so that these things should come to the school level, like Pythagoras theorem. Pythagoras theorem, much before Pythagoras, it was in India. but we don't know. We did it as Pythagoras theorem, and he never gave it in the proper form. The form that we did was given in India, not in the West. That we are told that we were uncivilized people. We got this civilization, everything from West. We should know what is our heritage. That is why I started this. Maybe you will be able to attend the second one after a month. There you will see many modern things. These are the old things, the basics in the school level. What you read in college or university, that also we'll discuss. Or maybe in the next lecture, if I the concluding lecture, there also we'll discuss many things. Thank you, Sambhu. Please switch on your camera so that we can take a snapshot.
Regarding this education or all these and all, yes, sir. I wanted to say that all these formulas and all everything is written in Sanskrit. Shloka is complete formula about that circle, how to calculate the area of the circle without using pi. So in a Sanskrit shloka it is written. So we have a already Sanskrit curriculum in school. So why they can't just introduce some of these things in the Sanskrit instead of just shlokas and some stories. So I think that will be a better to start introducing the things.
Yes, that will be nice if we include these things, our heritage into our curriculum, then when we go outside, nobody can say us that we have no contribution. India had no contribution because we will be equipped with the knowledge of what our predecessors, what our ancestors knew, and we can take it from there. That is possible. And Sanskrit nowadays it is not very difficult. Even if one does not know Sanskrit, nowadays courses are available. Short courses in 7 days one can know Sanskrit. That is not very difficult nowadays. So even if one is unaware of Sanskrit, there are short courses for Sanskrit. Just to know how to learn Sanskrit is easy.
Yes, sir. Thank you, sir, for this information. And I like to share that all the things have been shared in this presentation. I had little bit of idea about all the things, but that was not in a proper way. Now I can gather the things and I can means accumulate the things in a proper way. What our ancient India has. Basically, we have engineering, mathematics, gravitation, and astronomy, means space science. Everything was there, but it was not given to the Indian people in a proper way. I think it's the propaganda of British. I don't know what's the politics there, but we had everything which is not given to Indians, and it should be given in near future.
Yes, I agree with you. Thank you. Thank you for your comments.
Thank you, sir. And sir, I would like to request if you can give some presentation on modern Indian temples actually. So what I heard is temples are the best example of science, heritage, and archaeology, mathematics, everything. So if you can explain on something on that and Indian temples, I think it will be a good lecture, sir.
I'll try. I'll try to get the information and put it in the form of a presentation. That I'll try. I
Thank you, sir.
requested those who attended. So if you have got some information, please spread this information among the younger generation. So that we knew Pythagoras theorem, we knew gravity, we knew Newton laws. Please spread this among the children or the young generation so that they will be aware and they will be enthusiastic to search for these things. Okay, thank you. We'll close here.
Thank you, sir.
କେତେଜଣ ଆସିଲେ? 40 କୋଉଥିରେ ୟୁଟ୍ୟୁବରେ